Okay, folks, I think we can start taking places. We still need to figure out a couple of technical details, but yeah, you can start picking your chairs. We still have some left. Is there anyone in the back that is not yet here? Okay, we're gonna start, I guess, in I don't know, 5 minutes, maybe less. We'll see. Really nice to see you all. Uh, there will be, there will be this part, and I will be talking mostly to you. But then we will have some people on a live stream, in YouTube, and we're gonna start this live stream in, I believe, no time. I don't know. So I have to figure out what to do with you right now. In the meantime, so if anyone prepared some jokes, I would really use that. Okay, no, I can we ask like ChatGPT to generate some jokes? There is no one. I'm talking to no one. There is no one there behind the computer. um. Okay, folks. Yeah. We will have 3 presenters today. And I think the level of the presentations will be outstanding. I will give you a spoiler. All of those people have PhD in what they do, right? So they are certainly not amateurs. So for the presenters, like no pressure, no expectations. Take it chill. I hope you're gonna deliver. So we are still not ready with the live stream, and I'm kind of not having anything prepared more to tell you. Uh, but yeah, maybe let me quickly check. Are you all folks from Barcelona, or you are from somewhere else? Like I would assume you are from Barcelona. That would make a lot of sense. But is there anyone that came specifically here from, I don't know, from Portugal maybe? I mean, it's next door, right? Okay, no. Oh, like someone there, like literally 2 people. That's great. That's great. We also have more visitors from our company, the company that is hosting this talk, that came from places like Poznan, Poland, Warsaw. I think we have people from UK. We have pretty much people from all around Europe. Okay. Are we live? Just checking in, Natalia. Yeah, we can start. Okay. So, one more time to the people out here, welcome you in this beautiful setting. And to people on the live stream, welcome you as well. So, OLX Masterclass, this time about GenAI in Barcelona. We have had a couple of those events already in different places across the world. But let me tell you this one, never had that kind of setting and view behind my back. It was pretty dull last time, honestly, compared to this one. I'm not gonna lie. So, and one more remark, because I spoke to some of you, right? And I just have to admit that among all the engineering communities sort of that I spoke previously to, you're among the nicest people in those communities out there. That is just a fact. And it's super excited to be here. And we have a technical issue slightly. But don't worry, I'm gonna figure this out in a second. Great. Um, Agenda. Introduction pretty much done. We will have 3 amazing talks, as I mentioned. After the first 2, we will have a coffee break, and then we will have the last session, and we will go straight into Q&A. So the questions, we will take them at the end, right? And in a second, you will see a Slido link. So please take your time and log in. If you want to ask some questions, we will use that. Obviously, we will allow some live questions happening here. And this is pretty much, the whole thing that is standing between us and the pizza and networking that will be happening after. So let's go into one more thing. Yeah. Up. Spoiler alert. Yeah, that's not playing along well with me. Back to Slido. Here is the link, right? Use that link, log in, ask questions. We will be, the four of us, three presenters and me will be sitting here answering them after all the presentations are being done. And before we go into the presentation, into actual presentations, I want to tell you a short story about the company that's hosting us today. So we are kind of, I would say, if I don't math correctly, we are legally allowed to have beer in majority or actually all of the Europe. So we are kind of long time on the market, and we have a couple of well-known brands across those European, well, not only European, but for now at least, we're gonna mostly focus on those brands across Europe, and a lot of products in our portfolio. Some of you, two folks from Portugal will know them and from other places. But what I really want to tell you is that, or maybe, can anyone try to guesstimate how many active users we are saving daily? Like, Mariano, you are not allowed to answer. You were working here previously. Okay, anyone care to guess? The hint is it's in the millions. 12 millions. Pretty close, good guess. So 14 millions, yeah, we have some kind of award for you. You were the brave one to take a guess. 14 million daily active users, give or take, obviously. There are peaks, especially if we count kind of bot traffic. There's a huge issue. Hopefully, GenAI could solve that at some point. Though that number will be higher. So we are present in a lot of European cities. We have a lot of products in different markets, and we have a big scale, right? Which means we have huge obligations towards the customers that uses our products daily. And those are some of the locations I mentioned, right? Poznan, Berlin, Lisbon, your kind of neighbor. And then, well, Rio de Janeiro might not be essentially in Europe, but we, as I said, we are present in a lot of other countries as well. However, what are we doing right here? And well, the answer couldn't be different. We chose this location. This guy represents GenAI. We chose this location to create our technological hub for GenAI innovation, to serve that 14 million users daily, to to help scale our product and help our products teams that are working in all of those beautiful locations. And we believe like there is a huge potential in this hub in Barcelona to deliver on that promise. Now, without further ado, I want to invite our first speaker. And our first speaker is our Chief Data Officer, Andreas Merentitis. He leads AI innovation at OLX. He is a data expert with over 20 years of experience, background in machine learning and algorithm optimization. That is a thing I had to note. He has a PhD in statistical signal processing. Kind of not trivial, not trivial thing to have a PhD in, I guess. Well, Andreas, stage is yours.
Thanks a lot. Thanks a lot, Kuba, for the kind introduction. And I would second that. This location is indeed amazing. I've been on several of our hubs, and I think this is probably the best oral for sure in the top 3. Thanks a lot, everybody, for joining also. Hopefully, you will find that as an interesting presentation, what myself, Paula, and Paul will present today. So I will talk about GenAI at OLX with the theme of rethinking the product experience. Yes. But starting a little bit from the more basics, before going to GenAI in particular, I will talk a little bit about innovation. So a lot of times people talk about strategy, and it's important to keep in mind what strategy is for a commercial organization, what strategy is for a business. And the quote that I like is that it's a combination, it's a path that is a combination to achieve growth and profits. Because of course you want to grow your customers, to have more customers. You also want to be profitable from the perspective of the stakeholders and the business. And for both of those, sustained innovation is really critical because it leads to customer satisfaction, fuels growth, but it also leads to competitive structural advantage, which also leads to profits. So the entire goal of strategy is to create imperfect competition is a quote from Gary Hamel. Now, looking specifically to computer science in particular, this is an area that you can argue that it has the most successful sustained execution in business history. Taking an example from 1965, IBM released the first mass-produced hard disks, which were a bit more than 7 megabytes, and they were costing $2,000 per megabyte back in 65, with the cost, the value of the dollar back then. Today, a Seagate Barracuda of 8 terabytes costs 0.00015 cents per megabyte. So obviously, much bigger capacity, much smaller price tag. Just to give you an analogy, if the same level of execution had happened in the car industry, that happened in the computer science industry, then a Mustang of 1965 would, that cost back in the day 3,300 euros, would have been able to run with hundreds of thousands of kilometers per hour, and it would cost 1 cent. So that is that is the level of type of innovation that we have seen in the computer science domain in the last 40 plus years. And this is not all. A quite interesting discussion and talk that we had seen recently at OLX in one of our leadership events came from Peter Hintzen, who talked about never normal. And you can see that the trend of how innovation actually works, it's accelerating. So in the past, you might take 8-10 years to do a big innovation cycle. Now this time gets shorter and shorter and shorter in the effect of 2 or 3 years or even less. Another thing that people typically tend to expect, humans tend to expect when it comes to innovation is a linear trend. They expect that things are proceeding in a linear pace, and then you go from there. But typically, this is not how it works with innovation. Things quite often start slowly. They have this S-shaped form, and then they accelerate, might reach even exponential growth, and eventually flatten out when they reach a level of maturity at a peak. That is very important to have in mind because it also affects how people and companies perceive and react to competition. You can see exactly that S-shaped curve here with the blue line. And generally, when you have an incubated company that has developed a specific product that addresses a market segment, quite often you will see that a new challenger comes, and that challenger in the beginning is offering a product that is not so good, but eventually, because of the exponential growth, it will get better, and then at that point, of course, it's already quite late to respond. So with that overall mindset of innovation trends, I will talk a little bit about our AI strategy at OLX as a next step, and try to connect that to the overall thing that we heard before, and then of course to also some concrete use cases of what we are actually doing already today in the product and what will come in the near future. So of course everybody has heard about GenAI. This graph presents the rate of adoption for ChatGPT as it came out, and the time it took to reach 100 million users in terms of weeks, and compares it to every major digital platform that had come before. And you can see that it was basically the fastest ever in history. And that's not all. If you see the rate of progression of machine learning models, in this case, going back to the 60s and 70s, of course, much, or at least in the 90s, much before GenAI. If we consider as maturity the level of human performance, before it was taking decades, literally, and in some cases even more, in later on years to reach that level. But in the era of GenAI, it takes perhaps 1 year or even months, and the pace of iterations gets faster and faster. And that ties, of course, also the faster innovation cycles that I showed you earlier from the never normal. It also ties to the pace of innovation in computer science in general that is much faster than in basically every other field in the last 40 years. And that doesn't seem to be also slowing, because the level of publications, which of course are tied to funding in many cases from the top universities and top big tech companies in the world, you can see also that it clearly follows an exponential trend. And this funding does result in actually creating innovation. Of course, not everything is working from all of those papers, but those that are working push the field forward. And these two graphs are quite tightly connected. So with GenAI, from the perspective of OLX, what we want to do is to reimagine completely the shopping experience, both from the perspective of new listings and how you create new listings, make it as easy, as user-friendly as possible, as well as from the perspective of the discovery experience and making that as easy, as intuitive as possible. And this can be a paradigm shift. We are still not there yet, but we see already the first parts of that. So the questions that AI is posing is, can it change the classifieds business through a different user experience, as I was a little bit already hinting in the previous slide? Can it disintermediate OLX traffic? So can it pose a threat for us? But can it also be a means or an opportunity for OLX to trigger and grow its ecosystem? So these are the three key questions that we are trying to answer from the perspective of GenAI strategy. And in response to these three questions, we created what I will share in the next slide. So this is the innovation approach that we are facing, that we are putting together as a GenAI strategy that consists of three streams that we call optimize, scale, and disrupt. In the first stream, we are basically saying, in the current product, in the current experience, as it is working today, where can we apply AI in order to make it better, more intuitive, faster, easier for the users? Then on scale, we are saying, okay, now we have this capability. Can we enable the team to move faster, to experiment with the best tools that are available with the least possible effort and friction? Can we abstract all the different major LLM players and providers and allow teams to quickly change between them? Can we create reusable IP that will help us move fast in this space? Can we create shared capabilities that the different customer units and categories and verticals that Kuba shared previously can build on top of and customize their user experience? So this is the scale part. And finally, we have the disrupt part, which is creating ecosystem opportunities and increasing touch points to the user and potentially rethinking and changing dramatically the entire experience. So here we are talking about things like conversational buying. That might be a completely different paradigm based on agents. You can say, okay, I want to sell this, I want to buy this. And let's say, AI agents take part of this work and do it for you. We are experimenting, working very closely also with Prosus, our parent company in this field. We have already some early success stories and results. So this is how our super high level product roadmap in this area looks today. We have already some of the use cases live and in production that I will refer to in the next couple of slides. We started with GenAI for moderation, trust and safety topic, and for posting flow automation in some of the categories in horizontals and in motors. And from there, we are scaling to other categories. We apply it for job postings in our jobs verticals and for discovery experience. We also have already the MVP of the GenAI platform live, and we are moving some of the early success story use cases to that platform. And exactly the capability that it's offering is it abstracts OpenAI and Bedrock, and you can basically use Aether quite effectively, while at the same time abstracting all the complexity from the perspective of the teams and giving also a single report to our financial systems operations so that they can monitor the costs. And in terms of the disrupt part, this is a completely new experience that is based on conversational buying, as I said. The original intention was to have a live demo, but I think first we don't have the time and we also don't have the setup. If you want, you can take that offline and I can share a little bit more details on that. But this is an area that we are applying with a completely different experience where people can ask, I'm interested to buy a gift for my niece. What are your suggestions? You will get suggestions, then you might say, okay, but I want this brand, or I have that amount of budget, or can you compare side by side this and this model? And all of these are possible with GenAI today. And of course, when you want, you click something and you direct to pay and ship, and you can buy it. So concrete use cases that we already have live. Oops. Yes. This is a bit tricky. I agree with you. So the first one that I will refer to is the posting flow for horizontals. This is a use case where we are helping our users, our sellers, C2C sellers, to sell items through OLX. And we are talking about some of the categories where the image is really, really important. At the same time, adding all the details of the product can be quite cumbersome. So imagine that you are selling your shoes or your dress or a kid's item, kid's fashion item. And of course, then you have to select, this is the brand, this is the material, this is the price, this is the color, this is multiple other attributes like that. What we have done is that you basically take a photo of the item and almost everything is populated at once. So you will see the brand, the color, material, all of those are detected. The price also comes from a different model, but it's also detected or at least recommended. And basically you can still edit it as a seller, but all the hard work has already been done. And the majority of the time you just say, yes, click proceed. That reduced the time to post for those categories by more than 50%. And it also increased conversion quite significantly. I think for the specific fashion categories, 3 percentage points, which is quite high because it's not 3%. It's 3 percentage points from a relatively small conversion basis. So that was quite an early success story. And of course, we are expanding. We are trying to apply it to more categories. Not everything will work probably as well as fashion because it's not that the image is everything in some other categories. But building from here, it's looking quite promising that many other categories can be improved. And this is the result of the A/B test and the experience, probably some of the previous versions on how exactly it looked. Another one is image optimizing quality, and in this case, we are talking about image moderation. Generally, OLX being a two-sided marketplace, there will always be times that somebody tries to get outside of what is considered legal or ethical or basically violate the terms of service. And one of the things that we have is moderating the images themselves, so that they do not have nudity, drugs, guns, or anything else that might be a violation of the terms of service. And of course, we are talking, you remember the scale that Kuba mentioned, millions of daily active users. So we are talking also about many, many millions of images every single day that have to be moderated. And that, of course, is not possible with doing it with humans. It is already since many years done with AI, but today it is basically done already with GenAI and on top of that, traditional AI. So we have models that map the items, the description of the item, and the image of the item in the same space, create embeddings, and then basically on top of those embeddings, you can create different binary classification models that you can use for the moderation part. Or also, because you have that space, you can give to the moderators, the human moderators, the possibility to also find similar items and potentially auto-ban multiple, let's say, guns or nudity images or whatnot. So that also reduced, increased accuracy and reduced cost of detecting bad content by 15%. Another one that we tried was the real estate AI virtual assistant. So here the idea is that you go to this bot and you say, I want to buy a house with this and these properties, and basically find your dream house. So this is super interesting. It is also an example that I specifically picked because it is one that it actually did not work so well as expected. So as the previous examples, of course, not everything will work. We are experimenting. But it's also super interesting. It didn't work, but it told us that people in many cases will not search with what we traditionally have as capabilities of searching or applying filters in the platform. So they will not search by to I don't know, bedrooms and this type of price and property of the house itself. They will also search with, and I want a house close to there, or close to the school, or close to the theaters, or close to this and that. We don't have that information today, so we can see that a lot of those searches are actually unsuccessful. But it is also a good, let's say, input for product to understand, can we bring some of that back, and then we can reiterate and test again. So as of now, this product actually did not really work to the level of that we expected, but it gave us insights on what you can do still to improve the product in the future. And that is also quite valuable. GenAI platform. So I think this is already outdated, but we have around 50, a bit more than 50 ML models in productions with tens of millions of users as of now in OLX. Not all of them, actually only a minority of them are GenAI models. I think in the order of 6, 7, perhaps 8, something like that. But more and more are obviously coming. And as I said, the intention is that we make it as easy as possible for the teams to move fast, to experiment, to scale, and to do that in a way that you are enabled to use the latest models, the latest APIs, without having to create a lot of fuss on your own side. You can change vendors. You can still understand exactly how it works in terms of the same user metrics and report costs in a unified way. And this is exactly what the let's say mission of the GenAI platform team is. Already this is available. We of course will continue improving that. But the first, let's say, MVP that allows OpenAI, the existing OpenAI models, and some of the major Bedrock models is already in place. And finally, the third of the streams that I mentioned earlier from the optimize, scale, disrupt is, of course, the disrupt stream. Here, it's about moving fast and breaking things. And the two first examples is conversational buying and video-enabled classifieds. The first one, it's a collaboration between us, between our parent company Prosus, and between startup that we have hired to create the user experience. The idea is that we will try to see quickly and iterate fast what works for the users. Tens of thousands to begin with users, then hundreds of thousands. At that point, we will hopefully have seen where there is product market fit and where there isn't. We will bring back some of that on the core product. While the video-enabled classifieds is basically understanding, can we change our current experience to support video? And that might mean giving to the user the capability to provide images and a description of the item and create a small video out of that. And of course, there are many different iterations that you can imagine with houses, cars, our different verticals, how exactly that can pan out. Yes, that is a previous version of this OLX magic. We call it conversational shopping with multiple modalities. It supports giving information in terms of text, but also in terms of image and audio. Audio probably a bit more experimental as of now. And basically, you can also say stuff like, this is an image that I have of an item, or just snap with your mobile phone and take an image and say, find me the similar items in OLX. That is also something that can be quite promising. All of that, of course, is this stream is quite exploratory. It's in the disrupt area. It does not mean that we expect that all of that will work, but we do expect that we will have interesting learnings that we will bring to the core product and improve the experience. So thanks a lot. From my perspective, I'm super excited. I think that a lot of super good innovation will come for solving customer problems from this area in the next couple of years. So really looking forward to see what will come. I'm pretty excited because OLX is at the forefront of driving some of that, and this is super important. And I can also perhaps say that this hub here in Barcelona is going to be key for our plans. We are hiring actively for this area. So yeah, if we have people that are interested, or if you know somebody that is interested, please spread the word.
Okay, folks. Thanks a lot, Andreas. In terms of hiring, I learned that we have 17 people to hire, so that's quite a lot, especially if you consider the narrow field of Gen AI. So yeah, if you know anyone, let us know. Would be happy to have them here. Quick warm-up question to the audience. Was wondering whether we have like fans of ChatGPT versus Claude, right? So Anthropic Claude. Like, can you raise hands if you're more of a fan for ChatGPT thing? For YouTube folks, majority pretty much. And do we have fans for like Anthropic Claude? Okay, couple people back there. They know their stuff. Those couple people back there, certainly. I'm with you, by the way. Okay, folks, next presentation is upon us. Please welcome on the stage Paula Chocron. Hey, Paula. I will give a brief introduction of you. And as I said, we have a very strong presentations today. Paula is a PhD in artificial intelligence. She spent the last few years in developing NLP solutions in different domains. She now leads the data science team at IO Medical, working towards the fascinating task of automating information extraction from clinical text. And I guess the stage is yours. And go ahead.
Thank you.
Applause.
Yeah, thanks. And thanks for organizing this amazing event. It's great to see these kind of initiatives here in Barcelona. So yeah, I'm the data science team lead in IOMed, and we are a pretty small company. And as you probably don't know, but I'm telling you, we are actually focused on more like traditional machine learning and information extraction. So what I wanted to tell you now is a bit about how a small company like us is applying GenAI and large language models techniques to what we do. So this is how I plan to focus this talk. So first, this is IOMED, this is us. So a bit about us. We are, yeah, here. We are actually quite young and quite small. We are not entitled to drink alcohol yet, only 8 years old. We are 35 people, and we are mostly technical, right? We are like 20 people on the engineering team. The rest of us is on sales and products and etc. So our mission is, this is us. We have a beautiful office in the Recinto Modernista de San Pau. Maybe not as nice as this one, but really nice. So our mission is to build artificial intelligence and in particular natural language processing techniques to capture real-world clinical data. And what is this and why are we interested on doing this? Well, we're actually living on the prime time of clinical data. So really it's the most important time to get information and get like healthcare information from actual data from hospitals. So really it's important to understand. Is this working yet? Yeah. To understand really what we are doing and why we are interested on extracting this kind of information, it's important to understand that there are different kinds of clinical research studies, so medical research. One is the clinical trials, where doctors basically gather a lot of people and they do something on them, and then they analyze how these people react and the results. And then there are the observational studies, where basically we use information that is already there to see what happened with patients previously. So this is really where we are working on, and this is really where we can use all the data that there exists already in the hospitals. But of course, it's not easy to use this data automatically because of a few things. First, the information is unstructured, so there is a lot of information that is written. When you go to the doctor doctor writes some stuff about you. Most of this information is not also on the structured part, and it's quite it's different what you can find on each part, on the structured part, and on the text. So it's really important to be able to understand this information to really can perform research. clinical research. And then the other part is that information is siloed, so different hospitals or different clinical institutions use different kind of codifications, so it's not easy to perform research on with different information sources. So, right, what I'm going to talk about today. The first part is how data is stored in hospitals, so a bit about motivation, about why we want to extract information. Then I'm going to talk about NLP for healthcare data, and then I'm going to tell you a bit about how we are incorporating large language models into the tools that we are developing, really. So, okay. First, well, this is really working for me. Super strange. Okay, so the first problem, how is data stored in hospitals? Okay, so as I told you, shouldn't have talked. Sorry. Yeah, okay. So we have two different sources of information in hospitals. So we have the structured data, where we have basically tables, and the tables have columns, etc. So this is really easy to query and to extract information from there. But we also have the clinical notes, and as I told you, it's really difficult to get information from there because it's all natural language, where doctors write, and it's not easy to parse that in a way that we can make queries to that. So our goal is really to have everything on the same format, not only but also that use standard concepts, standard ways of referring to each concept, right? So we use what is called an OMOP database. This is a standard terminology that is agreed upon between all the clinical community, and our objective is to have both the Okay, much better. Our goal is to have both the structured data and the clinical notes on this kind of OMOP terminology, right? So this is kind of what a bit of like the general picture of what we do. So we have the clinical records, which is the text that the doctors write, and then the hospital data sources, which is the structured data, and we have different methods to turn all that into the OMOP database. I'm going to focus on this part because it's the natural language processing part, which is like what we do at the data science part, and where we are applying the GenAI and large language model techniques. So natural language processing for healthcare data. What is what we want to do, really? So we have this kind of text-based patient reports. For example, this one tells us about, well, the patient came in today and they have issues with diabetic control, etc. Then the patient has been on insulin for a long time. All this information, so all these patient reports are on the MOP database on a particular schema that is the nodes, right? They are on tables that have the nodes. And then there are some other tables that have different information, which is structured. For example, the procedures, the treatments, the diagnosis, etc. And as I told you, the information here and here is not really the same. So we have some things that are only on the nodes and not on the other tables. So our goal is to be able to extract information from the nodes, to be able to put them back on these tables so that we can perform queries automatically and get information for clinical research or for other applications. And so in this case, for example, we could get that diabetic is a diagnose, and then we put that on diagnose, then insulin is a treatment, we put that on treatment, etc. Quite simple. How we do that? Well, we have a natural language processing pipeline with different parts. These are the main models or the main activities, NLP activities that we perform, and I will tell you a bit about each of these. So the first part is really super important. As you can imagine, this data is super sensitive. So the first thing that we have to do is to anonymize everything, right? So we find here that there is a name, and we have to replace that name with something else, of course. Everything needs to be anonymized. Then we have the name entity recognition part. The name entity recognition is super important also. It's to extract the important words from the text and to be able to find like what they refer to. For example, we have pain, that's a finding. We have left arm, that's an anatomy. And of course, this is not so easy because, for example, we can have things that are not correctly spelled, like pian instead of pain, etc. This happens a lot because doctors are usually in a hurry when they write. But this is not enough. So we also need to be able to link these entities to what I was mentioning, that is the concept ID. So we need to find exactly what this refers to, if it's written in English, in Spanish, in Catalan, in whatever. And also, I mean, there are some things that can be referred to in different ways. So we need to be able to link all this to one particular concept that we know what it means. Then this is, again, not enough. We also need to find contextual information about these entities. For example, in this case, the text says, she visits for left arm pain. This morning the pain persists. She had similar pain when she had AMA. And we need to understand that this patient is not having AMA now. It's something from the past, right? So we need to understand this. Then it says she had taken nitroglycerin without improvement. Then again, improvement is negated. So we also need to extract all this information to understand exactly what is happening to the patient right now, right? And then even more, we need to extract relations between these entities. There is a lot of contextual information that is about how different entities in the text relate. For example, here, well, we know that the pain occurs in the left arm, that's a location, then some time relations, that it began yesterday, etc. So this is also super interesting because it gives us extra information, which is super important to understand what's happening with this patient, right? And finally, we also have other features that are also super interesting for clinical research. For example, we can identify mutations in genes, or we can find, for example, what is called reason for discontinuation, which is why a particular treatment was discontinued at some point. We have a lot of extra tools to identify particular information that doctors are interested in. So how do we implement all this? Well, we have models for pretty much each of these activities. These are supervised machine learning models. That we have different kinds of models. We can discuss that later. But from language models to LSTMs, really. So each of these tools implemented on a different way. We have an iterative learning process where we basically have these models. We perform a QA process which consists on verification and validation of the results of these models. And then from that QA process, we annotate more data to be able to train the models again and to have better results. And we perform this cycle until we have the results that we want, right? The metrics that we are looking for. So this is a bit what we have now, what we are doing. This is what we do at IOMED. And now I wanted to tell you a bit about why we want to, sorry, this is a bit about the training process, but now I want to tell you a bit about how we are incorporating large language models on this pipeline. I think it's interesting to mention that, well, this is how a small company like us does it. I'm going to talk about the challenges that we found and how we are dealing with that. And what we found was interesting on the path towards large language models. So, spoilers. So yeah, large language models and GenAI in general are great, but there are a few challenges for a small company like us. The first one was very basic, but really, we already have models. Yeah, our models already exist. Our clients are super happy with the results. Is there really a reason to change everything to go towards large language models or GenAI? Well, then of course the money factor. I mean, this is also what everyone talks about. It's definitely more expensive to deploy a large language model than a LSTM. Then when we talk about going towards this a different framework, we not only need to change the models, but we also need a huge change on infrastructure. Right? So we need to basically change how we deploy these models and how we put them into production. And then one problem that we haven't thought about, but which was actually one of the main ones, was that we have very sensitive data, as I mentioned, and most of these, so we can't use a commercial large language model service because we can't put the person's notes there, right? That wouldn't be right. So these are a bit of sorry, this is a bit misaligned, but these are the solutions that we found when considering these problems. So first of all, one of the most interesting lessons that we learned is that we need to find the problems that are correct for large language models. So maybe we don't need to apply them everywhere, but there are some particular things in which they provide value. They provide real value, and we need to focus on those problems. Then the money factor. When in some cases, large language models are actually cheaper than our current solution. I will show you a case right now. And we also need to find the right processing schema for this kind of models. Then the infrastructure changes. Well, we need to do that. There is no way. But we found that a good way of doing it was to start with internal applications and then gradually start moving towards putting everything into production. And then the sensitive data, well, we had to deploy an internal large language models infrastructure, which was a very interesting and challenging thing to do, but it's super nice. So first of all, we found a solution to build our own infrastructure. It was very challenging because, as I told you, we are a small company, and this is not something that small companies do most of the time. But we deploy our own large language model service using a combination of SkyPilot and yeah, I don't know how to say that in English. Well, PLLM in our own cluster. So we have our own large language model service, and it works quite well. If you want more information about this, you can contact our MLOps team. I'll leave you the email there so that you can send them some questions. Then a bit about the models. We found that, first of all, it doesn't really make sense to try many different models. We try to focus on just a bit of them, just a few of them, because it was impossible to try everything. We decided to focus on cost effectiveness because it was impossible to do anything else, really. It was we found that the most important thing here was that we could use them somehow. Another requirement was multilinguality because we work in different languages. And we started with Mixtral, but we quickly settled for Llama, which has many advantages. Also, that everything is public, so yeah, it's definitely a good option. I want to share with you some successful internal applications that we are working on, and we are actually using large language models. The first of them is using large language models as annotators. This is definitely the most interesting and the application that provided more value in our company. This is an example of a case where this is actually cost effective because large language models may be more expensive than other machine learning models, but they are cheaper than human annotators, right? So our current annotation schema uses two or more annotators for each example because they have to agree. And we asked ourselves if we can replace some of them with large language models. It works really well. It's having an hybrid system with people and large language models works really. It's really a great solution. The only problem here was to retrieve the label because sometimes the large language model gave different answers, was answering for a different task. So yeah, that was the only difficult part. But this improved a lot with good prompting, as always. So this is the most successful application that we have. Then there are some other things, like for example, this is of course everyone uses large language models for synthetic node generation or text generation. But for us, this is particularly crucial because the nodes that we use for annotating and for training our models are from hospitals, because we want them to be as similar as the things that the model is going to find in real life. And since they are from hospitals, if we lose the relation with that hospital, we lose all the data and all the annotation. So we found that use GenAI to generate text that is similar to the notes of hospital was a very good solution to be able to have something that is ours and annotate something that is ours, and not losing that if the contract with the hospital is broken. Another application is annotation translation. So we want to expand to different languages. This is something that we are doing now. And for that, we, of course, want to translate the annotated data. And traditional machine translation systems have a problem, that is that they may be very good, but they are not that good at translating a particular entity in a node. So if we, for example, have an annotation that says that this particular entity is negated, for example, it's difficult to find that particular entity in the translated node. Large language models are very good at doing this. It's straightforward. So this is really another nice application that we are actually using. Then these are internal applications, but then we also are exploring how to incorporate large language models in the processing pipeline. And for this, we have two insights mostly. One is to find the right problems, like where are large language models worth using, and the other one is to find the right processing schema. So maybe the iterative process that I told you about is not the best one, because we can't process all the time with large language models, so we can find a different way of processing. So for most cases, we use an independent pipeline for training. We use an independent pipeline for large language models, where we try to find problems where we only have to process once. So we basically, for example, this is one of the problems is node classifications. So instead of instead of classifying an entity, we basically want to classify the node somehow. For example, is the node a first visit, or is the node a first diagnosis, etc. So for that, we can do that once for each node, and then leave that on a different processing pipeline, and just don't do it again. Some other problems can't be solved like this, because they depend on entities which can change. For example, temporal relations, right? This is quite complicated for traditional machine learning models. For example, we have this text, for example, this appears a lot on nodes. Being 14 years old, the patient is diagnosed with urticaria, which developed into chronic urticaria 10 years later. And the question is, when did the chronic urticaria start? Super difficult. This is like something that you read and you say, oh, yeah, of course, but super difficult for models. Large language models instead are quite good at this. So we developed an hybrid system where we use large language models on demand, right, as a service. So we do extract all the information from here, so the entities from the text with our models, and then we call large language models, but particularly for these questions that are super difficult for other models. So we have different possibilities, different ways of implementing this hybrid system. Sometimes we ask large language models when other models can't find an answer, or when the other models find an answer, but with very low confidence. So to finish a bit, of course, we are going into, our vision is to use large language models in general, to have a fully large language model-based pipeline where we can do something like this, like ask the model, is this not about chronic urticaria? If it is, then we ask about the treatments. If there is a treatment, we ask about the treatment date. But for now, we are finding that these particular applications are good places to start, and to start exploring our way towards this future. Well, thank you very much. I hope it was
Well, perfect timing. Probably people here noticed that it started to rain, which, as you guessed, the equipment is not really waterproof. So it's a perfect time for like 15-minute break. Go inside, have a coffee, have a chat, ask questions, and we will try to, save the situation, I guess. figure out the rest of the technical maneuvers that we did. So I have to improvise one more time. Like I wasn't really prepared for that part. So yeah, audio is not really playing along well. I asked you previously about the usage of okay, of the ChatGPT versus Anthropic Claude, but I really wanted to ask also about the third group. Is there anyone who is really using your local machine to set up any model on their in their environment and ask questions? Anyone else? Okay, 3 people, 4, 5. Okay, pretty savage, I must admit. Like, what kind of machines you folks? I tried to run some of the models actually. I mean, my MacBook can take it off. I guess you have some kind of NVIDIA hardware. No? MacBook? How much RAM? Yeah, but depends on also which model. If you get a really big one, and even if you quantize it, like that's yeah, yeah. But then I was, like my dream would be to run one of those really big models on local machine, right? And not have to wait like I don't know, 10 minutes, 15 minutes, 20 for an answer. Like literally seeing every not even like token generated, right? Next to each other. That's not the best experience. But if your calculation are correct, yes, those are true. And well, I guess we should all trust you given your background. Yeah, it's indeed it's a matter of time. Yeah, that's what I would expect. In the meantime, switching the topics, we can any questions to whether Andreas or to Paula about their previous presentation live from the audience. We can try to have them right now, and then maybe as we go back live, we'll move to the presentation. All your questions are in Slido. That's why you are so shy. Cool. Yeah, we should definitely prepare next time with the I don't know the nice video to entertain everyone with. And apparently, thanks a lot. And apparently, we are live again. Hopefully that is true. So YouTube folks, welcome, welcome back. We were having a lot of fun here with people in the audience and with the equipment. You have to trust me. Okay. We are after the break. We had 2 amazing presentations. Well, I spoke to Paula actually during the break. I wanted to sort of emphasize that those presentations were really practical. I mean, they were about practical aspects of the AI usage, and that was truly interesting. There was like the level of technical details were just just enough, and then the practical aspect was really was pretty much a game. And now with the last great presentation for today, let me welcome on stage our last presenter, Paul van der Boer. Paul began his career in aerospace engineering before earning a PhD from Carnegie Mellon University. He then worked in digital and data analytics at McKinsey & Company and co-founded the Data Science for Social Good organization in Europe. Currently also, Paul is working on token AI, which I guess you're going to check also. So, stage is yours.
Thank you, Kuba. So when we had a discussion about where we should put the next GenAI hub for OLX, of course, Barcelona was one of the candidates. I said, such nice weather here in Barcelona. I came in from Amsterdam today, looking forward to something where it would be obviously sunny and not wet. Looks like that. But anyway, good to be here. What I'm going to be talking about today is what we do at Prosus. So as Andreas mentioned, we're the formally the parent company, but I see it more like cousins together all the time with, of course, with OLX. We've got others, the group that are here in Barcelona, like the folks from Global. But we're actually a very large tech investor across the world. So we have about $100 billion valuation currently, with many different companies that we operate across various locations in the world. Most of the brands you won't be familiar with. For example, in India, we have Swiggy, PayU, any others like Misho. In Brazil, we have iFood, which I'll talk about a little bit today. But across the portfolio, it's about 1 billion consumers we serve. And we've been doing lots of different things in AI over the past decade or so. And as we transition into Gen AI, we've learned a bunch of stuff, and I think it complements nicely with that Paula and Andreas have shared, and that's what I'll talk about today. So there's 3 steps in the story today, because what I want sort of you to take away is that as we're trying to bring Gen AI into the organization, we actually need to do one thing first, which is make everybody, which is at least a choice we make, everybody in Prozis, all the folks working in the company, not just data scientists, need to have an understanding and an intuition for what AI, and in particular now Gen AI, is and is not. And I'll tell you what that means. Everybody needs to become an AI power user. The second thing is identifying the use cases where we can have real business impact and measuring that, because at the end of the day, we're operating companies. We try to measure what the impact is of all this AI investments that we make on the nature of the business. So that's the second piece. And the third I've called scaling laws. I'll take a broad definition of what that means. Because we operate at such large scale, we've seen the dollar signs of Paula, right, earlier. Obviously, for us, that also matters. So we at the scale of, for example, OLX, we talk about tens of millions of listings that get uploaded on a weekly basis. If you put any of the GenAI LLMs behind any use case there, we immediately see the dollar signs flying around. So we'll talk about what the scale, in particular at the Prozis level, is for GenAI. Okay, so I'm going to take a different case here. As I mentioned, we've got many different businesses in the portfolio, but because you've heard about OLX already, I'll take iFood as a story, which represents some of the effort that we're also trying to replicate across the rest of the group. And in fact, iFood journey in AI didn't start when ChatGPT came or when a lot of the Gen AI became mainstream. It started much earlier. And we've worked, I would say, about, let's say, the last half decade or so to really create that AI engine that drives the business. And I'll talk about, in particular, some of the latest things we did along the way. But it started with obviously creating data teams, which I think some of the many organizations have gone through since then. Also going pretty aggressive in building local teams. So we've made several acqui-hires, in particular in Brazil, this business in Brazil, food delivery. We've made sure that everybody understands and uses GenAI on a day-to-day basis through Tokan, which I'll talk about. And now we've got a GenAI engine, which has about 150 models in production. Has a little faster. Go 150 models in production, which means real use cases where we measure business impact, right? And it manages those models. As I mentioned, we're operating at a pretty sophisticated scale. They just celebrated 100 million orders a month. Really, really big party in Sao Paulo last week, because that was a big milestone that they met. But under the hood, that means that we're doing a lot of predictions, right? So you can see some of the numbers here. Some of the things I'll talk about when we talk about power users is the number 91%, which is the number of users that use the in-house process-generated assistant called Tokan.ai. But of course, we also measure the business impact, which I'll show and talk about in the use cases. So we estimate about 30% if it does directly the result of some of the AI use cases in production at iFood. Okay, so starting with making everybody a power user. How do you do that, and what have we done in that space? Like I mentioned, we have an in-house AI assistant called Tokan, and the biggest companies in the portfolio use it. There's 24 companies. We've got about 3 million questions answered of Tokan in the past, I would say about 24 months. It was released about the same time as ChatGPT. We see that in the latest calculations and surveys that we did, It saves folks about 47 minutes a day on average, 12, 13%, depending on the length of your working day. So we see real impact. And I'll talk about the underlying costs and the way we built this thing. One of the reasons we do this is trying to understand how does it change our work, right? I think most of the folks here are technical, so you're probably using Copilot, ChatGPT. We had a few Claude users. I'm a fan of Claude, for example. But there's also lots of other folks in the organization. We've got about 30,000 people in Prosus globally, lawyers, folks in finance, marketing, every type of profession. How does their work change as a result of these assistants? Now, because we have our own, we can tag the conversations and we can ask, are folks using it for software engineering or for content generation? And so we've analyzed that, and you can see, quite interestingly, that about half is related to what we say is engineering tasks. The other half is related to other general content stuff. We track the quality of these answers and models over time. In particular, days had this little Pinocchio, right? We can affectionately call it, is basically the hallucinations, right? We tracked that very, very closely. That was an issue before. It's still an issue, but far less, right? So we now understand. But more importantly, we understand when the Pinocchios occur, but users are, I think, much more naturally suspicious and have an intuition for what types of questions they should ask, right? Nobody here in the audience would ask, hey, Alexa, can you make me a coffee, right? You know that that's a dumb question. Well, there's a certain category of questions that for these kinds of assistants like ChatGPT and so on don't make sense, or at least you should be suspicious of them. So one of the other things we learned here is this, as we try to make everybody an AI power user, is that everyone's day changes a little bit, right? And at the beginning, we had these discussions, as a side note, that are these assistants business critical, right? Because we're setting up agreements and we're bringing it into the companies. Business critical. Chatbot down. It's not like an API that's serving, moderation or payment gateways or these things. It stops if you can't serve. Well, now I can tell you if Tokan goes down, my phone starts ringing, right? Because folks say, hey, listen, I can't work without this thing, right? Like our workflows in Slack are broken. We got a whole bunch of teams that are using customer support and so on. And if you look at how the day changes of folks, it's not that a share of your day, those 47 minutes, you go home 47 minutes early, right? Because it doesn't work like that, right? You've got a whole bunch of stuff you're doing throughout the day. And when you're about to get stuck, you go to your assistant. And that can be ChatGPT, it can be Tokan, it can be whatever. It's sort of workflow augmentation, is micro productivity. And it's been helpful to understand because, the 30,000 folks in our group, they're white collar workers, right? There's folks sitting behind a computer. So a lot of the work or a lot of the benefits are in small parts of their work. Things that normally would take 2 hours, they can now do in 5 minutes. And we see that over and over again. And that's kind of been helpful for us to understand how do we make sure that the benefits are reaped by different parts of the company. One of the things that we also saw in the tagging work of this conversation, doing surveys, is that some of the use cases, or many of the use cases, are related to data analysis. Now, we estimate there's about between 5 and 10% of all the employees in the group have a data analytics role, right? It can be business analyst, can be data analyst, analyst. And we started to build solutions specifically to help those people serve answers faster. And we built the Tokan data analyst. You can see the example of Glovo. We have Pablo and others in the audience who can tell me, keep me honest here on what we're doing. But I think Glovo's been an enthusiastic adopter of this solution. And what this solution specifically does is it integrates this assistant capability with, in this case, Glovo, but also iFood and OLX and others, databases to allow folks to get answers that are related to data analysis immediately, instantly. A lot of technical questions we had to solve along the way. It took us about 18 months to get to the accuracy that we wanted. But once it works, it's a big time saver. Like I said, between 5 and 10% of folks are actually, their job is to do data analytics across the entire group. So if we can help the other 90% who depend on this 5 to 10% to get answers quicker, that accelerates a whole bunch of things, and you can increase the organizational velocity as a whole. In some of the measurements, just to give you an idea, I said 47 minutes a day for the average sort of kinds of questions that we see. But for this particular types of use case where people are looking for data, and you'll have experience with this on your own, sometimes the data, getting the data, the answer to your question, actually, not the data, the answer to your question can take much more than 23 minutes, but on average it's 23 minutes. We bring that down by 74% by using tools like the data analyst just for folks to self-serve using these kinds of assistants. Let's see. All right. So I'm sharing that with you because, you know, our CEO says if we want to become, you know, one of the best AI companies in the world, everybody in the company needs to become an AI power user. So this, you know, this was step one in getting AI into production, is have folks experiment with all these models. Tokan actually is, and I'll share a little bit about that in a second. It's the front for many different models out there, not just the LLMs, but also image generation and so on. Once people start playing with that, they discover their own use cases. And some of the use cases I'll talk about are the ones that were identified or will be using some Gen AI in the near future. So I'm going to stick with iFood and its AI engine. And I'm going to look at a couple of use cases where we've been very specific at quantifying the impact of AI on the business. So on customer acquisition, we've got the before AI and without AI. One of the things that actually matters for us a lot is besides, as I said, customer acquisition, I meant fraud prevention. In particular in Brazil, when folks make payments through our platform, there's a lot of fraud that happens, right? There's all sorts of very creative schemes that people come up with. You know, I'm a restaurant, but not really. And maybe they do that in Glovo too. And I'm an eater and not really. And so we had to deal with a lot of fraud. And that number at some point became completely unsustainable. The market rate for chargebacks in Brazil healthily is 0.5%. At iFood, we were dealing with almost 3%. So that became an issue. That was about COVID period. And then we needed to basically find a way to smarter about detecting which were potentially fraudulent restaurants, you know, linking particular accounts and so on. And at some point, we were able to develop a sequence of models together with the iFood team. It's the Aldrin family of models that were much, much better at predicting fraud eventually than what was market average, right? So that took a sequence of 3 years where it was a system of models that allowed us to become much more accurate at detecting which orders were to be accepted or not. And you can imagine these are numbers that affected bottom line directly, right? So at the scale of iFood, 100 million orders a month, a 0.1 percentage point difference makes a huge, huge difference. So you can see the numbers here. The GMV in reais, if anybody's from Brazil, is about 5 billion in June of 24. Again, so 0.1% difference on increasing the GMV because it's not lost through either through chargebacks or because you deny the payment is quite significant. Another one, and this is a use case I think will be familiar to many of the companies you're probably working with or for, is in the customer support side. So if you think about the food delivery marketplaces, you got basically 3 types of customer support that we need to deal with in iFood's case. One is riders. They come with questions. Hey, which restaurant do I need to go to? They don't have my order ready, and iFood needs eaters, right? Hey, where's my order? Late. And third, restaurants, right? They're trying to onboard, they have questions. We've got 3 streams of customer support tickets. And one of the things we've been trying to do, and this is something that started way before GenAI, but we're doubling down now with GenAI, is automating those 3 streams. So drivers, customers, and the restaurants. And you can see that at the moment, you know, these numbers are going up. I think generally we've set a pretty ambitious automation target of 80% across these 3 streams. We can see that with GenAI, that becomes much easier, right? So at the beginning, you start with simple use cases like classifying or categorizing tickets, summarizing tickets. And as you kind of go on and you start using LLM and using some of that basic reasoning, you can do many, many more things to increase the key metrics, improve the key metrics, in particular automation, but also cost to serve using GenAI, while, by the way, increasing your CSAT. So in this case, actually CSAT improved at about 5 percentage points, in particular on customer and driver automation. The third piece here is on personalization and search. Again, I'm picking this one because I think this is one which almost every company that has an online presence will have to deal with. And this is also one where there's a lot of AI models already in place. And now the question is, what does GenAI do for this system today, right? We've already been optimizing this for 5 years. All these different types of models that are, some are very sophisticated, some are basic, that help us personalize and retrieve more relevant results. Well, GenAI actually can do lots of things because a lot of these models depend on accurate data quality. You need to tag dishes. Is this pizza? Is this sushi? Is it Asian? Is it Italian? Is it vegetarian? Is it a family meal? And so on. All that stuff we're now enriching and improving the quality of. So these models, without changing much, can do their job much, much better. Because instead of having no information on the, let's say, actual attributes of these dishes, they can actually bump the impact of whatever they're doing the recommendation system much more accurately because the data they work with is better as well. Okay, so on scaling laws, a couple of things. So besides making sure that we quantify the impact of the use cases and the investments we make, you also try to understand where's the puck moving, right? Like what's around the corner when it comes to GenAI. So a few things on that front. I think one thing that's fairly obvious, Andreas also alluded to this a little bit, I think, is intelligence is going to become more abundant, right? So if you take the projections of Anthropic, of their Claude models, we're now on the blue side. We're going to get better. And that doesn't really matter if you take Anthropic or OpenAI or some of the other predictions. If you just continue the dotted line, the models we see today are the worst they'll ever be, and they're going to get a lot better. Okay, so let's put that together with something else, which is the costs. So one of the things we typically look at is what's the intelligence per dollar, right? So how much can you get done with a specific amount of budget that you have? Not all tokens are born equal, right? Not all of them are equally useful. But if you look at the last 6 months, you can see a tremendous drop here already, right? So it's about 79% cheaper for the GPT-4 family of models. And we're seeing that across some of the open source models here as well. We've been looking at, for example, Mistral and Llama for a lot of our use cases. And you can see these are drops, all of them that took place between May and August, right? So a lot of stuff happened in that period. A lot of big models were released, but cost of those models also dropped significantly. To give you an example of why we track this pretty closely, sometimes unexpected things can have a big impact for our use cases. So we very rarely have English-only use cases. We often have non-English. So a lot of these models came with new tokenizers that were much more non-English language friendly. So the language tax we used to pay 6 months ago for Polish, for Brazilian, for Spanish, for other things, for Hindi in particular, the language tax sometimes was 3x or 4x. The same question in Hindi was 4x more expensive in tokens than in English, dropped even more, right? So this is on English. If you look at some of the non-English languages, the cost went down even more. Okay, so intelligence becomes abundant. The intelligence per dollar goes down. So what happens to our overall cost? I have a question. It's a question to you. What do you think our overall spend is doing? Like, I look at my OpenAI bill, my Anthropic bill, my NVIDIA bill. Well, it's more AWS bill, but should be going down. I wish. Should be going up. Yeah. Well, I'll give you a use. It's definitely going up. Okay. But why and how much? So I actually thought I'd look at some real numbers. I took the token numbers here in the last 3 months, and I normalized them to May, right? And I said month over month, what's the percentage increase on one cost per token? Okay, we just inherit those costs, right? We don't decide. It's from the external providers or the GPUs. 2, the tokens per question. So how many tokens do I need to answer a question? 3, the total of dollars per question. right? Because I know those two things, I can multiply them. So let's look at each. So our token usage per question went up by more than double, right? And that is because we're now working with agentic workflows. So we launched a big change to token, like, similar to GPT-0.1, where you're spending a lot more tokens to answer your question because you're thinking, right? You're reflecting, you're critiquing, you're going back here, and so on. So we use a lot more tokens. We can do many more things as well, but the tokens go up. Second thing is that price per token dropped, like I showed in the previous chart. We did just cheaper models and open source. And the third is users are asking more questions, and that's the big problem. Well, it's not a problem, it's a good thing. We want that. They're becoming power users, right? They're like the fact that there's now agentic workflows, which are much better, much more useful, they're faster. So at the moment, we're still increasing costs. In 3 months, 18%. Let's see the next 3 months, because a lot of stuff changes, but our cost curve is kind of like this. So for predicting, it's extremely hard, right? Okay, then one final comment to finish it up before we go to questions. Because this math that you just saw that I did for token, we obviously do that for all the other use cases as well. And you can see that this sort of fluctuating thing makes the CFO really nervous, right? And we've been very aggressive, in general, at just go, right? Just build, explore, find value. That's the objective. First, find value, make it work. 2, make it faster. 3, make it cheap. Right? So that's been our motto for most use cases, and that flies. But to one, make it work, right? You need to understand which models perform at which level. So we have a leaderboard called Pro LLM, and it's based on our own benchmarks. Pro as in real production LLM use cases in our languages, in our universe of non-academic benchmarks, basically. You can check it out. It's public. And you can basically go to any of the benchmarks we've made public. For example, Stack Unseen we own Stack Overflow, so we look at their data. There's a lot of recent data that the models haven't trained on yet. We know that the data isn't polluted with the training data, so we look at how new models perform. And you can see, if you go to this particular benchmark, how, for example, how incredible the bump is for a 1, right? On this particular coding task. I had a discussion with someone earlier. It's so much better at math, they said, and we have tried it for coding, and we see this is an incredible bump, right, compared to GPT-4 Turbo. And we do this within hours of the model being live, right? So every time a new model comes, we need to know how well does it perform. And if you look at the previous page, not this one, whoa, exciting. One more. There we go. This one. You can see that you can filter by coding language, by difficulty, by question type, because we know within token and many other use cases what people are trying to answer. So that allows us to understand, if we're trying to mitigate cost, dollar costs, what's the cost for quality, right? Can we afford moving to a cheaper model, or is that going to make the user experience much worse? Speaking about skill, some things don't skill, right? What you're looking at is a picture I took on Monday, that's yesterday, of our office in Amsterdam. This is the head of tax. This is the head of comms, someone in finance, someone in legal. It's basically folks, my colleagues at Prozis, who are participating in a labeling party. And we basically give them free pizza or other food. And we have a labeling party, and we ask them go in and label this data. Sometimes it's images, sometimes it's documents, sometimes it's code. Not with the tax folks, but depending on what you're trying to do, you can invite different people. And that is important for us to create high quality benchmarks that we feed into token to the assessments, right? That stuff doesn't scale. It's really great. So if you have colleagues that are non-technical and you want to engage them in the stuff you're doing and you're tired of data labeling yourself, I recommend pizza and data labeling parties. It's a good way to involve the rest in the organization, and so they generally like it. It's a good way, again, to develop that intuition about what is actually happening under the hood. Last and final thing is a little bit related to scale in a very different way, but this hub here and many of the other ML practitioners that work in the Prosus umbrella group are part of a big global community. We have about 1,000 ML practitioners that are part of the group. We organize one event per year. It's called the Prosus AI Marketplace, where we also invite external folks from the ML ops community. The theme this year is agent in production. A little bit. We always pick a theme that we're kind of, it's kind of running ahead of the curve, because we do have agents in production, but I can count them on one hand, right? But the goal is to basically share learnings about what it takes, what are the struggles, to have an honest conversation with builders, folks that are in similar companies, similar challenges. Event is streamed live, and we're looking forward to it. We're going to have folks in the group participate and invite also externals. With that, I think we're ready for questions with three of us, I think. Paula, you're still here? Yes. Thank you.
Okay, folks. Can I have Andreas, Paula here? We need some chairs. Actually, we're gonna put them in front. I'm gonna, I guess, need some other microphones. If they are working, that would be really helpful. Okay, I was it. Yeah, I will actually. Yeah, I can take this one. I will try to read the question as well. I'm not sure if we're gonna have more mics, but I'm gonna handle it. Okay, we will have one more that is coming. Okay, for now, Andreas, you will get it. Okay. First question: how do you measure AI-assisted posted ad versus manually posted versus potentially hybrid? Any conversion impact, positive or negative? And I guess, Andreas, that is regarding your presentation.
Yes, indeed. So exactly, it's a great question. Of course, we have devised the A/B tests that exactly test for that, and you can test on the posting flow what is the conversion in the different steps for exactly these types of variations. So if you have human crafted ads, if you have ads that are basically humans just accepted the input of GenAI, and cases where humans accepted 90% of the input of GenAI and edited the last part. Generally, the GenAI and hybrid are the ones that have the highest conversion, and I think I was probably rushing it a little bit, but it was quite significant actually. So it was 3 percentage points higher than completely human edited ads, and the reason is that in those, or at least the hypothesis is that in those relatively cheap categories, many people will not take the time to optimize every single field, which of course affects quite a bit also the conversion on the posting flow itself. And at the same time, quite interesting, and going also to what Paul said, it affects the other side. It affects the buyer side as well, because you have now better data to actually do better recommendations, better sets, and so on. Especially for those relatively cheap categories, this makes a significant difference. If you are talking about cars, less so, because there, of course, people will have the motivation to put everything correctly and optimize. But for those categories, it actually makes a difference and increases conversion on the posting flow, but also on the buyer side.
I will actually add one thing to that, because in one of my teams, we are also leveraging the same sort of idea. One of my teams is working in jobs category. So those are, job offers. This is the perfect use case for LLM, essentially. Like, take any description, job description, generate it, and that's pretty much it, right? It's not, well, in a way it's creative, obviously, but maybe not as creative as some of our users describing, I don't know, their toys that they want to sell. So we see a huge positive impact in time to complete the posting, and people are very much less likely to drop posting their job offer when they are using actually either an LLM or a pre-made template that we actually used LLMs to generate in the first place. So this is a real business positive impact that we are seeing from this specific feature. By the way, folks, you can also vote on the questions, right? So you are seeing them on Slido. You can vote on them. If there's anything specific you like, it will bubble up to the top. And then the next one: are we using LLM to judge ad by checking titles, descriptions, images, features, I guess, etc. Titles with unnecessary spaces might be flagged. Can LLM detect these quickly? I mean, probably again Andreas, but that's actually a really good question to you as well, because relatively generic use case.
Yes. No, indeed. Actually, we do that. Right now, it's relatively simple things, pretty much some of those that are mentioned here as well. Yeah, for those types of use cases, for sure, LLMs can improve that. It is still at the level that is arguable what is the improvement over traditional autocomplete and autocorrect and whatnot, because of course these exist for a long time. So it's not that LLMs are significantly better today, but at the same time, they give you a possibility to have, let's say, tagging of the quality of the ads, and that is quite interesting in terms of insights for the overall portfolio, and also again as an input for other downstream tasks, because we might say, okay, these ads that are higher quality, we want to promote them by that percentage from our ranking models that are on the other side. So this is something that we have started a little bit experimenting with. It is not that it is the default system in production today. And generally, we are doing it in a way that you are trying to get most of the benefit without making it super expensive. Because again, going back to the unit economics discussion, we are talking about tens of millions of listings. So the unit economics will for sure go there. And as Paul said, the trend is improving dramatically. It doesn't mean that every use case is viable today, depending also on what type of benefit you get if you compare with simple, let's say, autocorrect and autocomplete.
Yeah, actually, Paul, can you actually go next to me? Apparently, you are not visible on the camera, so actually, maybe I will put you in the middle. I mean, come on, man, you're the important person here. Okay. Actually, maybe I want to sort of extend this question to you as well. Any similar use cases across our companies in portfolio?
Yeah, I think in general, we have a pretty good understanding of what can impact conversion. So I think spaces in the title isn't necessarily one I would put up there. But for example, quality of images, big, right? So in the food space, making sure dishes have an image, and then that image is good and representative is leads to a lot higher conversion. So those are the kinds of things we'll then focus on. Descriptions of ads in OLX, super important. In Stack Overflow, having the right question title, right, is important. So typically each business will have a really good idea of what they want to start with. And that's what we then focus on. And depending on what that problem may be, we pick a different solution. Often LLMs these days, but not always.
Sweet. Okay. Next one. And I guess this will be how many POC implemented are still working on production after 6 months and with positive ROI? I guess that's again sort of to either Andreas or Paul.
I think at this point for OLX it's super high. So the only example that is not live after POC is basically the real estate AVM use case, the virtual assistant that I presented explicitly because of that, because it is the only one that actually didn't work. And it had still interesting learnings. The learning was that users are not searching by the property of the house per se only, so number of rooms, number of bedrooms, and whatnot, floor, but they are also searching by proximity to points of interest that we do not necessarily have on the platform today. Every other one that we have tried today, after perhaps a couple of iterations and so on, has been a success. So basically, I would say it's above 80%. The rate of use cases that are active today after the initial POC or MVP stage. Now, this is, of course, obviously the early stage and the low-hanging fruits. It doesn't mean that it will be 80% forever, but it gives you an idea of where we are today. And as Paul said, typically every side of business knows where are the biggest opportunities. So, of course, we are not picking randomly. We are going after the biggest opportunities.
Yeah, I will add one thing, which is, I think it was in your presentation, Paul, do things that don't scale, really. Like this is, we start looking for a value. We actually, sometimes we sort of overpay in terms of the infrastructure versus the maybe customer impact in the first place. But we're really looking to validating whether the value is there in majority of the cases. And we have some models that were, well, maybe too expensive to run in this scale that we've been talking, 14 million of users daily for now. but we validated that, you know, they provide a value, and now we need to find a better way to optimize them. So if they don't made it through that, you know, 6-month mark or whatever, initially it doesn't mean we're gonna, you know, come back to them, especially as those scaling laws and everything applies, and we get better at in terms of the infrastructure and the cost efficiency. The next one then, and it is for Paula. Great presentation. And the question: how do you prevent large language models to use your data for training, I guess, on certain models?
Yeah, this is really one of the main challenges that we had. I mean, we couldn't use any kind of commercial service for our data because it's data that comes directly from the hospital. It's super, super sensitive. And really, we have very specific contracts that tell us what we can and cannot do with this data. We can train models, but we can't do anything else. And we can train models only on our servers. So this was the main challenge that we had. And our solution was to implement our own infrastructure for large language models. And this is what we are doing now. So we are not using any kind of commercial service for this because it's impossible. There are some services now that are starting to provide some warranties that they won't use the data for anything else, etc. But as you can imagine, this is very difficult. It's very difficult to convince hospitals or any other really public institution that this is going to work. They don't trust this, basically. They say, no, it's your server or anything else. Mostly, in some cases, we have to process everything on the hospital servers because they don't even want this data to be externalized to our clusters. So it's super difficult, and the solution that we found was to implement our own infrastructure.
Cool. The next one, a bit more technical, I guess. How do tokenization methods affect the performance of different models? Who wants to start?
Or I can start, but I will pass to Paul.
Everyone wants to answer this one. Right?
Yes. No, Paul is the expert actually, so I'm not so sure that I can provide that level of depth and detail. So generally, tokenizers do play an important role, quite important, especially when we are talking about different languages, which I think Paul mentioned also before, that if you are talking about English, things were traditionally much easier, and now it gets more friendly for other languages, also in terms of cost, also in terms of effectiveness. From our perspective, we are not optimizing, at least from the perspective of the customer-facing business, tokenization per se. We are optimizing the whole customer experience. So that's part of what we are looking for. Eventually, we are comparing models, though, which come with their own methods of tokenizing. And finally, it is an A/B test that validates the user outcome at the end. But I'm super curious to learn a little bit more, and I will pass to Paul, that is the actual expert on that.
The lecture is not about tokens, so I'll keep it short. But so the reason tokenizers are, and I'm fascinated by them, is because they are the entry point to how the model sees the data. And we have finally, thankfully, started to standardize on tokenization, right? So the reason that's important is because, one, the way the data is tokenized governs what models you can use. Two, like I mentioned, you might know this, but the GPT family of models were trained on the World Wide Web. 93% of that data is English. 93% of our data, in Prozis is not English. And so the tokenizers were optimized traditionally for English. So if you move to code, which, for example, Stack Overflow or other use cases that we have, the tokenization is really expensive, right? Because almost every character, every letter gets tokenized separately. And so there's a lot of room, which now finally we're seeing some of the latest models are taking, to improve tokenization, to improve also the learning rate of these models. And in fact, we've seen that in the latest GPT models. Like I mentioned, we went to the 200K encoding. So it's 200K vocabulary list. This is the size of the vocabulary for the tokenization. And before I talk another 30 minutes, to answer the question, the reason this matters is the non-English language tags to us. That's the most important thing, the reason that we've been paying attention. Two, the ability to easily switch between models right? Because if different models use different tokenization. A simple example of that is when we route to different models, we need to know what is the context window of that model. Can I use this model as a fallback or alternative to that model? Context window matters. So we're calculating the size of this particular input in tokens to that model. But if every model uses a different tokenizer, that becomes a pain in the you know what. So the fact that now it's standardized already makes it easier for us to route to many different models. And the last thing, and this is more for the future, but think about all of the other modalities we're trying to feed these transformers, or to feed to these transformer models. Genomes, proteins, amino acids, other things that can be tokenized as well. And we're, one of the things we do is we invest in companies that do more state-of-the-art frontier deep tech work on this front. And, companies are trying to discover or build genomic frontier models, foundation models that create and synthesize new materials. They need to understand how they tokenize a molecule, right? So there's an entire new world in understanding how we represent different modalities, like I said, amino acids, proteins, and so on, in an efficient way for these large language models, generative foundation models to learn those structures. And we pay attention to that because that's something we need to solve for the models to really learn the underlying mechanics or representations in text, but also biochemical data and so on. So.
Well, that was great answer. I must admit that was really good one. Okay, the next one. So I guess keep the mic because this is about process again and cost predictions. In your experience, how important is the energy consumption in the final amount? And how do you envision the future costs? I guess again in terms of the energy as well.
It's a good question. So we pay. We have two types of bills. There are GPU hour bills. How many GPU hours did we consume? And how many tokens did we consume? So I don't see the energy consumed. I don't know. So in fact, I can't really answer this question, but it's no secret that whether you're paying in tokens or GPU hours, a really large fraction of that bill will go to energy. And we have seen, and if you've read the latest Llama paper, the 16,000 GPUs that Meta used to train its models, they were struggling getting the energy into their GPU cluster from the grid. So I know that it's an important primary input to inference in particular, but also during training. But unfortunately, I don't really know if it's 80% or 50%, but it's clearly an important input.
So actually, I kind of wanted to make a spin-off from that question, right? Because we need to put so much energy. Those models are clearly getting better and better, right? Every year essentially. But is there any point in time really that they will get as efficient as human brain? Like what human brain is using, like 20 watts of power, and we are talking about megawatts, right? So realistically, we are not gonna be outperformed anytime soon, I believe. This was more of a comment rather than a question, I guess, but kind of this question sparked this one. Okay, we can go to the next one, and then you have talked about the use of AI contributed to 40% of your EBITDA. Apart from the increase in productivity of the employees, how did you quantify that?
Well, it's a conservative estimate of two things. One is how much did we reduce costs of certain processes like customer support, data tagging, fraud, right? We can actually measure that directly. Second thing is how much did we increase revenue, right? Could we grow faster because we recommend things better? Can we scale to new cities faster because we have a better optimization algorithm? We can add new areas of the city. And so on. So that's how we calculate that. And as Andreas and I have had many discussions about how do we quantify these things. This is a conservative estimate because it's very, very hard to, and it's the dream of many of us, I guess, in the AI practitioner, the builder community, is to say this model contributed $15 to this process, right? Very hard to do. So this is the part that we could actually reasonably quantify. I believe the impact is probably much larger, but it's done by summing up from, in this case, an iFood. There's an iFood number, 150 models, summing up each of the models over time, looking what we believe is the financial impact cumulatively.
Exactly. Perhaps just to give you a bit of an example from OLX, we are measuring the impact of roughly 20% of our models as direct monetary impact. This is already on the tens of millions per year, low tens of millions. But this is only basically, as I said, 20% of the models. So if you were able to estimate everything, it would be much larger. Pretty much the same case for iFood, I'm pretty sure. So these estimates are very conservative lower bound. It probably is much higher than that.
Okay, the next one. There are infinite use cases for GenAI. That is correct. Which criteria do you use to assess if GenAI is worthy to implement? Maybe we can start with Paolo now.
Yeah, I think this is really the main question that one has to ask themselves. It's the key, I think, is to find the right applications and to say, okay, yeah, this adds value to the company and this doesn't. And I think if you do that well, it will be successful for us. Clearly, for example, the large language models as an annotator application. That's a successful application for sure, because there we are saving money for sure, and we made experiments and we found that we have the same quality of annotation. So I think it's as they say, it's super difficult to measure in some cases, because it's how much are you saving, how much are you winning quality. But I think the key is to try to find right applications, and that's my advice to any small company who wants to start adding these technologies.
Perhaps I can. That's an excellent answer already, and I think it covers 80% of the cases for sure. Perhaps on top of that, I would add that from a perspective of a slightly bigger organization, we are seeing it as a portfolio of use cases, and we want use cases that are more sure bets, and this is what we call optimize stream. We want also some use cases that are higher risk, higher reward, which go a bit on the disrupt stream that I was mentioning in my presentation. So we are aiming to have representations of on both sides. And on top of that, we have given a guideline that 70 to 80% of our efforts should be spent on optimizing the core product itself and not internal efficiency, because of course with that we will work with Prosus. We can also have external companies and other tools that will help. And it also perhaps is a bit less critical if the core things that or not the core thing, sideline optimization comes for, let's say, customer support 2 months later because we didn't prioritize that versus prioritizing the core product. So that is another thing that we are using as an overall guideline.
Paul, want to add to that?
I think
Sure, that was amazing answer. Will there be job offers for non-technical positions?
I think, Kuba, I can jump in here. They gave me a microphone. I'm here. Kuba, here, just in the back.
I mean,
no, but I was given a microphone to answer this one.
So by the way, for anyone viewing this on YouTube, there is a person in the back answering this one,
sorry.
right? We just you can come up to the front if you want.
I can do that if you want to. Find that. So hello.
The voice from the outer world, essentially.
That's all right. Hello, everyone. I'm Basti. I'm heading TA for OLX. I think the best probably kind of to answer this. So for now, actually, for non-technical positions, we're not kind of looking for this actively. What we're doing right now is focusing on building the GenAI team for Andreas, more or less, right? So really kind of focusing on technical positions. We have seen kind of like Barcelona as one of our locations where we really see talent potential for the technical stuff. So GenAI, and that's what we're kind of doing right now. Building up the team. If there's going to be some non-technical positions in the future, I mean, if the hub is growing further, there might be, but for now, there's no plans of this. So we're really focusing on the technical positions right now. And you can, by the way, find them all on our career page. So if you're interested, just have a look and just kind of apply there, right?
Yeah, that was a perfect talent acquisition answer. I really love it.
We do have a few product roles. I don't know if you consider them technical or not, but yes, we have product and tech roles primarily.
Yeah, that's actually an interesting one, because we like previous question about the practical usage of AI, right? We really need to nail that if we want to get value out of this. that's where the product people, for example, comes in, right? And then like a product manager for AI or a Gen AI use cases, this might be kind of considered non-technical. But realistically, those are also very technical people. Did I get it correctly that ProLLM is interpreting a question and routing it to the best model for the job, taking into account also the cost? I guess that's the one for you.
Yeah. So I think this question is about Tokan, our in-house assistant, because that's where we get the broadest set of questions where we need to make those kinds of decisions. 6 months ago, we had a system in place, which is sort of basically when a question comes in, there is our own model that was routing it and predicting which model that question need to go to. And then you actually have the actual model answering the question. Now we've moved to an agent based framework where we basically have a big prompt with the most powerful model we can get our hands on that decides what tools and what models are used to answer that question. And some of the most powerful tools include things like code execution, but it also includes for other tasks things like SQL generation, long text handling and summarization. Each of those tools use various models. So for, let's say, for summarization, we had Llama 3.1 running for a while, 70B. We switched back to GPT-4o Mini. I can talk about why, but so there's various tools. We'll use different models. And indeed, the choices we make on which model to use, they change almost weekly based on the results we get from the benchmarks that you saw. And all of the models we use today didn't exist 6 months ago. And I'm sure that all of the models that we'll use in 6 months don't exist today. So we're continuously refreshing the model garden.
Great. The next one then. What best practices can power users adopt to structure prompts in a way that maximizes output quality while reducing the need for multiple iterations? So essentially, I guess that's a prompt, how to do a great prompt engineering out of this.
Right? I have a very, very, very simple answer to that. Maybe you guys are different, but it's like, I'm Dutch, right? So when I try to teach someone to bike, my kid, for example, who was here, I can talk all I want, but in the end, he needs to get on the bike and ride it. And then he'll learn, right? And for me, prompt engineering is like that. And you know what the great thing is? ChatGPT, Claude, Token, they're always friendly. Doesn't matter if you ask 500 stupid questions or dumb questions. You know, if you do that to me, then at some point I might get tired, right? These assistants don't care. So go out there, try it, refine it again. You probably have lots of problems. Every day you wake up tomorrow, you want to do things, you want to analyze this, look at that data, get an answer here, create that. Use assistants in as much as you can. That's the only way I've found to really get folks to learn, because in the end of the day, you need to get that sort of intuition. It's like, Alexa, make me a coffee. We all know that doesn't work, but you have to try what it does do well. And the reason that it's important is because these models and what they can do changes, like I said, month over month. So trying it is the only way to learn it. Unfortunately, I don't have a really, we do have a list, right? Being precise, detailed, and so on, but you'll find that out by trying.
Pablo, Andreas, want to add something to that?
I think Paul pretty much covered that. I did. The keyword is you have to try that and it changes super quickly, and some of the, let's say, more detailed fine-tuned approaches that you have learned in Claude will not apply to let's say ChatGPT and whatnot, vice versa. The other thing is that as models evolve, it also changes by that. So the new, let's say, Strawberry model that was just released explicitly says do not use chain of thought prompting because it basically does it internally. So that is also something to keep in mind. So basically you have to learn by trial and error and adapt. It's not going to be stable.
Okay, I guess Andreas and Paul covered it. So the last question of the day, directed at you, Paul, again. What do you think about agents building in-house solution to cut costs on software as a service applications like Klarna? And is it possible for Prosus with its many brands?
So agents building in-house solutions. So we're talking about AI agents.
building apps essentially, right? Or recreating some of the most popular apps. By the way, if there is a person who asked this question, you can clarify. If not, we will try to make the best out of it. I guess agents are solving problems like some of the software as a service apps, or maybe even to the point of building those solutions.
Yeah, I think I've tried to answer. So if you can buy it, you should buy it. It's sort of our general advice, because unless it's competitive edge, and we've again had discussion together, like what are the things you invest your team's time in? Because there's an infinite number of use cases. If you can get a simple customer support solution out there you can buy that's affordable, buy it and focus on building the application internally that you differentiate on. A listing, uploading workflow that makes it better, or car valuation model, or whatever. So we're pretty agnostic to how you solve it, at least from our perspective at Prosus, is get going, try it, discover the value. We have a very bullish view on this space. So the more use cases, the better. The more experimentation, the better. The more use cases you pull back out of PSC because they didn't derive value means you learned something. So I think in terms of the SaaS specific things, there's a lot of great SaaS solutions, right? So use Salesforce, use UiPath, use all these things if they make sense. Don't rebuild them. I don't think this GenAI space is going to suggest we should rebuild them. So I hope that answers your question. But
yeah, hopefully. I mean, this was a great answer. So that was the last question, standing between us and the pizza, I guess. So it's about.
Are we gonna label data with the pizza, or is it free pizza?
Well, it's a free pizza, unfortunately, because we didn't spoke to you previously. Man.
I have some data we can label.
If you have it, we will do it.
Next time.
Okay. So I wanted to say thanks to our amazing presenters. I wanted to say thanks to all of the organizers. They did a outstanding job, bringing us here, making this happen, making this work. As you see, the equipment doesn't really work with your support, like your quest, but we made it through. So thanks to everyone. Thanks especially to people watching us on YouTube. And I guess right now officially we can go and have some fun, have some networking, and last round of applause.
Thank you.